Hello, let us see syntax directed definition. Before starting the syntax directed definition, we will see one thing, that in case of C programming language, consider an array of size 10 and 20. This can also be thought of as, or written can be thought of as, array of size 10 which holding another array of size 20 which is again an integer. Or let us take another example, that float 10, 20, 30. This three-dimensional array can also be thought of as, or its equivalent type expression can be array 10, array 20, array 30, float. So these are what they are called the type expression. Now let us take another example, that double of size 10, 15 and 20. The corresponding type expression of this array can also be said in this way, that it is an array holding 10 which is again an array holding 15 which is again holding 20 array which are double. So these are the type expression of a particular array. Now in this particular video we will be discussing how to generate the syntax directed definition for an array so that the corresponding type expression can be generated. So the problem is that is write an SDD for an array to generate the corresponding type expression. So what is our objective? So our objective can also be represented in this way, that is, we have to develop a particular syntax directed definition whose input will be an array. For example, the input can be integer 20, 30. This is the input. So and the corresponding output will be, that is the type expression, that is, for this particular situation the output will be array 10, array 30, integer. So we have to generate this syntax directed definition. So how we can do that? In order to generate the syntax directed definition, first of all we have to concentrate how this array can be generated using production rules. So let us concentrate on that. So we can use the following production rules to generate any array. So this will be T produces this BC, and this B produces integer, B produces float. Here we are considering only two data types, and other data types can also be considered in this similar way. Anyway, and this C produces num and C1, and this C produces epsilon. So before starting generating the SDD, let us see how these production rules can be used to generate any array. So let us take this array. So this array can be generated in this way, that T produces BC, and this B produces integer, again this C produces num, C1, and this C1 produces num, C1, and this C1 again produces num, C1, and this C1 finally produces 10, and this num is basically 10, this num is 20, this num is 30. So if we see the tree, then we can see int within the bracket 10, within the bracket 20, within the bracket 30, and concatenated to epsilon. So we can see this array can be generated by using this parse tree or these production rules. Now let us move how the corresponding semantic rules can be generated for this particular situation. So again let us write the production rules. So these are the production rules. T produces BC, B produces integer, B produces float, C produces num, and C1, and C produces epsilon. So these are the corresponding production rules, and here we will be generating the corresponding semantic rules. So how these semantics rules can be generated? So this is nothing but a programming. So before start generating the semantics rule, let us try to build some intuition on the generation of semantic rules. So let us take for a simple example, that is int 20, 30, 40. So how the things will be generated, we can see that. So the production rules are applied in this way. B produces integer, C produces num and C1, again this C produces num and C1, again this C1 produces num and C1, and this C1 produces epsilon. So let us see how the attributes can be evaluated so that the corresponding type expression can be generated. So the first thing is that if B produces integer is given, we can create an attribute type for B. That is, we can say that B dot type is equal to integer. Similarly, we can say that B dot type will be float. So in the first case, this will be evaluated in this way. So 1 is in the first case. So we are writing 1 here to denote the order. So B dot type, so the type of B will be integer. So this is evaluated in the first time. Now we have to transfer the information that the array is integer from this attribute along the tree. So how we can do that? So first of all, this information that the type of B is integer, that is, it is an integer array, this information is passed to the variable C. That is, the transfer of this information from B to C is among the siblings. So if we define another attribute type for C, then we can see the type attribute for C is evaluated from its sibling. So we can say the type attribute for C is inherited attribute. So this is an I attribute, but here the type is for B is synthesize attribute or S attribute. Now the type will be C dot type will be B dot type, that is, it will be again an integer. So what we are doing? We are doing that B dot, sorry, here we are doing that C dot type is equal to B dot type. So what we are doing now, consider this production rule, which is basically T dot BC. We are doing the transfer of information among the siblings. That is, we are writing that C dot type is equal to B dot type. Now see, the information is transferred from the left subtree. So this is the left subtree of T. So you can see that the information is transferred from the left subtree to the right subtree, or rather to the root of the right subtree, which is this C. Now we are now at this variable C. So here we can use another attribute. For example, we are using an attribute called code, that is C dot code. Here we can see the at value of the attribute of this C is equals to array this num value. For here the num value is 20, here the num value is 30, and here the num dot value is 40. So here we can say that C dot code is equal to array num dot val comma C1 dot val. What we are doing? We are doing that C dot code is equals to array num dot val that is the synthesized value of the variable num, variable denoted by num, comma c1 dot code. Now consider again this production rule. The production rule is that c produces num and c1. Here what we are doing, we are evaluating the attribute code for this variable c, that is we can say that c dot code is equals written as array num dot val. So the information is traversed in this way, that is array first bracket num dot val comma c1 dot code, that is c1 dot code. So you can see the information is flowing in this way, but the value of c1 is not known, so we have to evaluate this one. So the c dot code, value of the c dot code actually depending on the c1 dot code, but the c1 dot code is not evaluated, so you have to evaluate it. So this attribute is cannot be evaluated right now. Now we are moving, we are now at here c1, or when we are using this production rule c dot num c1, we can also transfer the type of the c to the c1, that is we can also say that c1 dot type equals to c dot type, that is the type of c, if the type of c is integer, then the type of c is moved down in this way. So we can say the type attribute for c is evaluated from its parent. So you can say the type attribute of c1 is inherited attribute. So we can say that c1 type is evaluated to be integer. Now again we are at this tree, or we are considering this one. Now here this is the production rule that c produces num dot c1. Again these semantic rules can be applied. So c1 dot code is equals to num dot val, and the num dot val is 30, or we can say write 30 directly here also, comma this c1 dot code. Now again the value of code of this c1 depends on this c1, but the value of c1 is not evaluated. So again we have to compute this subtree. Now according to this production according to semantic rule at here, the type of c1 can be evaluated, that is c1 dot type is equal to integer. Now we are at here. Now if we consider this one, here we can also again evaluate the code, which is code equals to array 40 comma c1 dot code. Again the c1 dot code cannot be evaluated, so we are at here. Now as whenever we are at this production rule c produces epsilon, we can use another concept, that is, and here also we also have evaluated c1 dot type to be integer. Now when we are at the production rule c produces epsilon, we can use the information that the type of the array, which is integer, has been supplied to this c1. So we can see the information. So we can, what I am trying to say, that the type integer is supplied via b to this c, again this c1, again to this c1, and again to this c1. So we can say that currently in this c1, the information that the array is integer, we have this information. So whenever we using the c produces epsilon production rule, we can use the semantic action that c dot code is equal to c dot type, because here the c dot type is evaluated to be integer. So we can say that c dot code is equal to integer. Now here you can see that the c dot code has been evaluated, so this c1 dot code can be evaluated to be integer. Now we can see the c1 dot code, this one has been evaluated, so we can directly replace this at here. So it will be array 40 comma integer. Now you can see at c1 this code is evaluated, so this code can be this should be c1 dot code, this should be c1 dot code, so this code can be replaced at here. So this value which is 20, this entire c1 dot code will be this one, that is here the array should be written, it should be array 30 comma array 40 comma integer comma integer. Now we can see the code for C has been evaluated to array 20 comma array 30 comma array 40 comma integer. Now at this place we have the information that what should be the type expression. So what we can do, this information, that is the c dot code, this value can be transferred to t. So we can say that t dot code is equal to c dot code. So the entire type expression is now available at c. So this is the way how the corresponding semantic rules can be evaluated. Next, let us take another example so the concept will be more clear. Consider this particular array. Float 10 comma 20. Now this array can be generated in this way. T produces b, c, here b produces float and c produces num c1 and this c produces num let us use c2 at here, and this c2 produces epsilon. So what do we have to do? In the first case, this information that the array is of type float and these are the 10 and these are 20. Now what we have to do, the array which is of type float, this information has to be transferred at here. So first of all, what will be happen, we will be using the production rule, that is if b produces float then b dot type will be float. So this information is traversed or transferred in this way, that is b dot type is equal to float has been evaluated at here. Now what we have to do, now the information that the array is of type float is available in the left subtree, so this information has to be transferred to the right subtree. So how we can do that, this b dot type value should be transferred to here. So c dot type will be float. So what we are actually doing, so we are using the production rule t dot bc and we are using the corresponding semantic rule as c dot type is equal to b dot type. Now at this in this in this subtree, what we have in our hand, we have in our hand that here that it is an 10 element array. So this information is in our hand, so we are using another attribute called code, that is we are using c dot code is equal to array num dot val, which is num dot val in this particular situation, num dot val is 10 for here. So num array first bracket num dot val which is 10 comma the code for this c1, that is c1 dot code, which is currently not available. Okay, now so what we are doing, we are using that if C produces num dot C1, then the corresponding semantic rules are C dot quote is equal to array num dot val comma C1 quote. And also we are using, or we are transferring the information, the type of C to the type of C1. That is, we are transferring the information of the data type from this parent to its children. That is, if we can think in this way also, that is C produces num C1, the type is known at here, and this known type is transferred in this way to the children. So C1 dot type is equal to C dot type, and we can also say that the type attribute for C1 is evaluated from its parent. So this type for this variable C1 is inherited attribute. Now the C1 dot type or its corresponding type is evaluated from here, which is float. So what we can see, that the evaluation of this C dot type is transferred from here to here. Now the next thing, again we are using the production rule that C produces num C1. So here the code for this C1 will be code array num dot val, which is 20 comma C2 dot code. Now here the value of C2 dot code is unknown, and the type of C1, which is float, is transferred to its children C2. That is, C2 dot type will be float. So what we can see, observe that the information that the array is of float, this information has been transferred from the left subtree to this C2. So this transfer of information is done by using only the inherited attribute, which are type. Now when we are using this production rule, the corresponding semantic rule will be that when we are using this production rule, what we have in our hand, the type of this C, we have this information in our hand. So we can see that here we are using the production rule C produces epsilon. So what information we have in our hand? The information is that the type of this attribute C2 is float is in our hand. So what we can do? We can do that C dot code will be C dot type. That is, here for this particular variable C2, we are using the code as its type. That is, the code will be float. Now you can see that C2 dot code has been evaluated. So this is the value of C2 dot code. So the C2 dot code is evaluated. So what we can do? We can replace the value of C2 dot code at here, which is float. So we can say that the C1 dot code is evaluated as array 20 comma float. Now you can see the evaluation of code attribute is done from the bottom to top. Now the code value for C1 has been evaluated. Now this value we have in our hand. So we can say the value of C dot code has been array 10 comma C1 dot code, which is again array 20 comma float. So the value of C dot code has been computed. Now this information, that is the code of C, which is this type expression, this information has to be transferred from this C to this T. So what we can say? We can say that whenever you are using the T dot BC production rule, we can use that T dot code is equals to C dot code. That is, the we are using this information, that is the value of or the code of C has been transferred from C to T. So we can say that T dot code is now array 10 comma array 20 comma float. So at this root we have this type expression. So these are the way how we can use the semantic rule to generate the corresponding type expression. So what we observe that the semantics rules are generated from the intuition which are built from a particular small example. Thank you.